Okay. Yeah. Visible? Good. Guys, in the last session, we discussed about daemon thread. What is the daemon thread? Huh. The thread which runs in the background is called as daemon thread. How to make a thread as a daemon? Set a daemon to true. By default, every thread is a normal thread that we create. If you want to make the thread as a daemon, then we need to call set a daemon. What is the example for daemon thread in the Java? Garbage collector. So garbage collector is responsible to deallocate the memory. JVM is going to allocate the memory. Garbage collector is going to deallocate the memory. So garbage collector will run in the background. We are not starting the garbage collector. JVM will take care of that garbage collection process. After that, we discussed about synchronization. What is the synchronization? What is the synchronization? Synchronization means thread safety. When we can call our program is thread safe, if only one thread is accessing our method, then that is called as a thread safe method. If multiple threads are accessing at a time, that means it is not thread safe. So program should be thread safe or not thread safe, that it depends upon the requirement. All right. So synchronization we can implement at two places. To implement synchronization, we are using a keyword called synchronizer keyword. Synchronizer keyword we can use at the method level and we can use at the block level. Okay, when to go for synchronization at the method level, when to go for synchronization at the block level. If you want complete method should be executed by only one thread at a time, then we will go for synchronizer method. In this method, complete logic is not important for me. Only some lines of code is important. Then we will go for synchronized block. Perfect. Good. Then after we discussed about this synchronized method, thread T1, thread T2. When I start these two threads, they are going to call the run method. Run method calling print numbers. That method is a synchronized method. It will first thread should complete the execution, then only second thread will start the execution. Because my method is thread safe, only one thread can access my method at a time. If I remove synchronized keyword, two threads will execute the method parallelly. Two threads will execute the method parallelly. If I keep synchronized, then only first thread will execute. After first thread execution is completely completed, then only second thread will execute that method. Practically, we are able to see that. Good. Now, let's go to our program. Let me take one Java class, new class demo. Guys, as of now, we created thread like this. Public class demo extends thread. Public class demo extends thread. Inside this, we are overriding run method. We are overriding run method. Can you guys tell me what is the run method? Can you guys tell me what is the run method? This run method is used to write the logic which should be executed by the thread. We are going for multi-threading. Why we are going for multi-threading? To execute our programs parallelly. So thread should execute my logic. Which logic you want to execute by the thread? That logic we are going to keep inside run method. System.out.println. This is thread logic. Something. I want to print this statement by thread. Then let's go for main method. Let's go for main method. Inside this main method, what we are doing? Demo D is equal to new demo. I'm creating demo class object. Demo D is equal to new demo. I'm creating demo class object. Then here I want to make this class as a thread class object. How to make this object as a thread class object? by using thread T is equal to new thread of D. Now demo class object became thread object. Now I am going to call T dot start method. I'm going to call T dot start method. Let's run this program. When I run this program, what is happening? Yes, I'm calling start method. When I call the start method, what is happening internally? Start method internally calling run method. My start method internally calling run method. This is one way of creating thread. This is one way of creating a thread. Now, there is another approach also to create the thread, that is called anonymous thread implementation. That is called anonymous thread implementation. Let me go to another class, new class as my thread. I'm taking a class with a name called my thread. Inside this class, I'm creating main method. Earlier in the demo class, I'm extending the properties from thread. I'm creating thread class object. Thread class object, demo class object I created. Demo class object I am passing to thread class object. Then I am calling T dot start method. I'm calling T dot start method. Here, I will not extend from thread class. Directly, I'm going to create object like this. Thread T is equal to new thread. Thread T is equal to new thread. As of now, I'm keeping semicolon here. When I keep semicolon here, what is happening? End of the statement. But now I will not end that statement. I will write like this. I will write like this. This is called as anonymous implementation. Inside this, I'm going to override run method. I'm going to override run method. System dot out dot println. This is run method. This is run method logic. T dot start. T dot start. It is the simplest way. This is the simplest way to create a thread. Earlier, what I have done, I have a class. My class is extending the properties from thread, and we are writing run method. Inside the run method, we are writing logic. Then I am creating object for demo. So demo class object, I am passing to thread class object. Then I am calling T dot start method. Then here I am not extending from thread. It is a normal class. My thread is a normal Java class. Inside that I have a main method. Inside the main method, what I am doing? Thread T is equal to new thread. I'm writing body for the object. I'm writing body for the object. Generally, methods will have a body. Now I am writing body for the object. So writing the body for the object, this is called anonymous implementation. What is this? Anonymous implementation. I'm creating body for the thread class. Inside the body, I am writing run method. With this, my thread is created. With this, my thread is created. Once this thread is created, I want to start the thread. I want to start the thread. T dot start. When I call T dot start, what will happen? What is it? What is a T? T is a thread. Inside the thread, do we have run method? Yes, that run method will be called. Right click, run as Java application. Is it executing now? Yes or no? Yes, it is executing. This is another way to create the thread. Now, I want to create one more thread, guys. I want to create one more thread. Can I go for runnable interface to create the thread? How many ways we can create the thread? 3 ways we can create the thread. What are the 3 ways? Extending thread class, implementing runnable, implementing callable. Now, let me go like this. Runnable R is equal to new runnable. Runnable is a class or runnable is a interface. Runnable is a interface. Can we create object for the interface? No. we need to create the object for implementation class. We need to create the object for implementation class. All right. Now here, instead of creating the object, I will create anonymous implementation for the interface. Are you guys getting my point? Anonymous implementation for the interface. Here also, I'm going to override run method. I can say system.out.println. This is run method. This is run method logic. This is run method logic 1. This is run method logic 2. I can say run method logic 1, run method logic 2. R is available. R is a variable holding which class object? Anonymous implementation object. Are you guys getting my point? Here T1 is having anonymous implementation. R is also having anonymous implement. This is shortest way to create the thread. This is the shortest way to create the thread. You can create the thread like this, or you can create the thread like this. You can create the thread like this. Runnable R is equal to new runnable. Runnable is an interface. I cannot create the object. I am providing anonymous implementation. For the runnable, I am providing anonymous implementation. Now, here R is available. Do we have start method in the runnable? In the runnable interface, which method is available? Only run is available. Why? Because it is a functional interface. Runnable is a functional interface. What is the meaning of functional interface? Only one method is available. Now, runnable interface, I can pass to thread T2 is equal to new thread. Okay, guys. Runnable interface, thread T2 is equal to new thread. Then I will call T2 dot start. T2 dot start. What is this? Creating a thread by using anonymous implementation. That anonymous implementation I am providing for runnable. That runnable object I am passing to thread object. Then I am calling start method. Execute this program. Yes, first run method is executed. Second run method is also executed. Similarly, can we create anonymous implementation for callable also? Yes or no? Can you tell me the logic for that now? Callable C is equal to new callable like this. Callable C is equal to new callable. Inside this, what method we need to override? Call method we need to override. Here it started, here it ended. Inside this, we can write the logic. System.out.println call method logic. Call method logic. Now, can I directly call C dot start or C dot run? Do we have any method in the callable? No. In the runnable, we have run method. In the callable, we have call method. Now, how to execute this callable now? Directly, can I create the thread object and can I call the start? No. What is the option we need to follow? We need to go for executor service. Executors dot new fixed thread pool of one thread I am creating. So I am getting executor service. Once I got executor service, can I call submit of callable? Yes or no? Yes. Now let's run this program. First approach, run method executed. Second approach, run method executed. Third approach, call method is executed. So here you can create a thread by extending thread class or by implementing runnable interface, by implementing callable interface. Here, am I implementing runnable interface directly from the class? No. Am I extending from thread class directly? No. Here, I am creating thread anonymous implementation. So thread T1 is equal to new thread body. Thread object is having a body. T is available. T dot start. When I call T dot start, internally it will call run method. Internally it will call run method. Now here runnable R is equal to new runnable. Runnable R is equal to new runnable. Here we are creating anonymous implementation for runnable. Runnable R is equal to new runnable. We are providing anonymous implementation for runnable. Next one, thread T2 is equal to new thread. Runnable does not have a start method. Runnable, callable are functional interfaces. Runnable is having run method, callable is having call method. Runnable R is equal to new runnable overriding run method. Callable C is equal to new callable overriding call method. Thread object I created. Runnable object I am passing as a parameter T2.start. It will execute run method. Callable C is equal to new callable. Inside the callable, we are overriding call. Am I creating the object for the callable? Am I creating anonymous implementation for the callable? Anonymous, that means without taking a separate class, I am implementing the interface. In the Java, this is possible. You can take a class and you can implement the interface. Without taking a class also, you can implement an interface. This is called anonymous implementation. Okay, once I have callable with the anonymous implementation, to execute this callable, I am taking executor service. Can you tell me what is executor service? Can you tell me what is executor service? It is used to execute a pool of threads. What is the advantage of going for executor service? Reuse the threads to execute multiple tasks. If you create a thread pool, you can reuse the threads to execute set of tasks. You can reuse multiple threads to execute set of tasks. Are you clear? Good. This is another approach to create threads in the Java. Okay, creating threads with anonymous implementation. Creating threads, working with the threads using anonymous implementation. Working with the threads using anonymous implementation. All right. Sorry. This one only, anonymous we will do. We don't create separate class to create the threads, right? Whenever I want to execute some logic by the thread, we will go for this approach. In every Java class. Huh? Less number of lines of code, right? You don't need to implement any interface from the class. You no need to extend the properties from any class. Directly we are creating a thread and we are executing the thread. Right? This is easiest approach and very less number of lines of code we are going to write. In the industry, mostly to execute logic by the thread, we will prefer this approach. No. It is anonymous implementation. If I end here, that is object creation. Sorry. That is what, man, anonymous implementation. This Java ka syntax hai. If I create like this, if I remove this, if I end it, then it is illegal. Why? Because it is a interface. Without having that interface, without creating the object, for this interface, I am providing anonymous implementation. Anonymous implementation, nothing but it is going to create one Java class internally. It is like creating a Java class, implementing a callable. Instead of creating a separate class and implementing an interface, Java provided this easiest approach to implement the interfaces. Got it? So generally, if I want to create a thread, then what we need to do? I need to implement callable. I need to implement callable. Implements. I need to go for implements callable. Right. Callable is available in the concurrent package. Callable. Then what should I do? Override the call method. Override the call method. Instead of doing all these things, whatever the logic we are writing here, this logic is equal to this logic. It is something like a anonymous inner class. It is something like an anonymous inner class. Whatever you are doing by taking a class, implementing an interface, overriding the method. Here we are writing this piece directly. Understand? I'm taking a class, I'm implementing a interface. Instead of writing a separate class to implement an interface, that interface I'm implementing anonymously. That means here it is something like an inner class without any name. It is something like an inner class without any name. In the Java, this is possible. We can implement interfaces without using a class name. That is called anonymous implementation. This approach you can follow for every interface in the Java. Not only for runnable, not only for callable. For any interface, you can follow this approach. Later, in the Java 1.8, this concept also simplified. How they simplified this concept, you know. Callable C1 is equal to they have provided lambda expressions. Directly you can write like this also. Directly you can write like this also. That is lambda expression in the Java. You can directly write the statements without writing any implementations also. That we will discuss in Java 1.8 futures. First, we are going to create a class which will implement the interface. To reduce number of lines of code, Java introduced a concept called anonymous implementation. To avoid this anonymous implementation also, Java came up with a concept called lambda expression that will be covered as part of 1.8. That will be covered as part of 1.8 futures. Good. So this is another approach to work with. This is another approach to work with threads using anonymous implementation. Working with the threads using anonymous implementations. Perfect. Yeah, you can do like this. Now you can write an example. No. This is not a method, man. This is object. It is anonymous implementation. This is not, I'm not writing method inside the method. Am I writing method inside the method? This is one method. I'm not writing that. This is not a method. Na? It is anonymous implementation. Method inside the method is not possible. But interfaces you can implement anonymously. Inner class, yeah. We can say it is anonymous inner class. Okay. And guys, this is Sunday. We have a long session. Whatever chota mota topics are there, we need to complete all those topics by Sunday. Sunday morning or evening. When is your comfortable? Morning only. Pura din kali aap. So some small topics which are related to garbage collection. What is garbage collection? What is reflection API? What is generics and inner classes? Some small topics are available. These are small topics. Tomorrow and the day after tomorrow we will complete. Okay, so tomorrow we will work on garbage collection part. Tomorrow we'll start the class. Yesterday I cancelled the class, right? Tomorrow I will compensate that. Tomorrow I will take the class from 5 to 8. Evening 5 p.m. to 8 p.m. I will take the class tomorrow. Sunday also I will take the session. These topics are not that much difficult. They are easy. So we can complete them in one day. So if we complete all these topics by this Saturday and Sunday, then from Monday we will start another big bull collections. Right? That is very important. Very important topics. Got it? Sunday ऑनलाइन ले लेंगे offline. I need to check morning one class is there. I need to check their timing. If they don't have class on Sunday morning, then I can come to offline, no problem. क्या फर्क पड़ता भाई ऑफलाइन ऑनलाइन? ह्यूज डिफरेंस हाँ. Okay, perfect. Now let's understand a small pending topics in multi-threading only. Deadlock. Deadlock. एक मिनट भाई. हाँ. Deadlock. What is a deadlock? What is a deadlock? हाँ. Deadlock, nothing but ambiguity. Deadlock means ambiguity. Deadlock means ambiguity. Deadlock means ambiguity problem among the threads. Deadlock means ambiguity problem among the threads. If two threads are waiting for each other to release the resources, that is called deadlock. I have given one. This is, look at this guys. Look at this. Look at this diagram. Look at the diagram. Deadlock means ambiguity. Deadlock means ambiguity. There are two threads, thread 1 and thread 2. Thread 1 holding resource 1. Thread 1 is holding resource 1. Thread 2 holding resource 2. Straight arrow represents that thread 1 is holding resource 1. Thread 2 is holding resource 2. Thread 1 waiting for resource 2. Thread 2 waiting for resource 1, but both are not releasing the resources. Thread 1 is keeping resource 1 and waiting for resource 2. Thread 2 is holding resource 2, waiting for resource 1. Thread 1 will not release the resource 1. Thread 2 will not release the resource 2. These two threads forever in the waiting state. These two threads forever in the waiting state. That is called deadlock. That is called deadlock. If two threads are waiting for each other to release the resources, if two threads waits for each other to release the resources, that situation is called as deadlock. If two threads are waiting for each other to release the resources, is called as deadlock. Once deadlock occurs, we cannot resolve that. If your program enters into deadlock, you cannot do anything. Whenever you are writing the program, you need to make sure deadlock should not occur. Once deadlock occurs in the program, then you cannot do anything. Okay. Once we get into deadlock situation, then we cannot do anything. We cannot do anything. We need to make sure our code will not give deadlock. Once you get the deadlock, then you cannot do anything. Deadlock means ambiguity problem among the threads. If two threads are waiting for each other to release the resources, is called as deadlock. Once we get into deadlock situation, then we cannot do anything. What is the example? Example, thread 1 holding resource 1 and waiting for resource 2. Waiting for resource 2. Here thread 2 thread 2 holding resource 2 and waiting for resource 1. Waiting for resource 1. Here thread 1 will not release resource 1, hence thread 2 will be in waiting state forever. Thread 1 will not release resource 1, hence thread 2 will be in waiting state forever for resource 1. Got it? Here thread 1 is holding resource 1 and waiting for resource 2. Thread 2 holding resource 2 and waiting for resource 1. Thread 1 will not release resource 1, hence thread 2 will be in waiting state forever for resource 1. Now here thread 2 will not release resource 2. Thread 1 will not release resource 2. Look at the diagram. Thread 1 is holding resource 1. Thread 2 is holding resource 2. Thread 1 is already having resource 1. Thread 2 waiting for the resource. Thread 2 holding resource 2. Thread 1 waiting for resource 2. Thread 1 will not give resource 1. Thread 2 will not give resource 2. Both will wait for each other. Both will be in the waiting state for each other. That situation is called deadlock. Once deadlock occurs, we cannot do anything. Whenever we are writing a program, we need to make sure that deadlock will not occur. Once the deadlock occurs, हम कुछ नहीं कर सकते. Are you getting my point? Right. So thread 1 will not release resource 1, hence thread 2 will be in waiting state forever for resource 1. Thread 2 will not release resource 2, hence thread 1 will be in waiting state forever for resource 2. Good. Thread 1 will not release resource 1, hence thread 2 will be in waiting state for resource 1. Thread 2 will not release resource 2, hence thread 1 will be in waiting state forever for resource 2. Thread 1 is waiting for resource 2, thread 2 is waiting for resource 1. Both are not releasing the resources. Our program will go to deadlock. Our program will never terminate. Our program will never terminate. That is called deadlock. Theoretically, it is very easy. Thread 1 is holding resource 1. Thread 2 is holding resource 2. Thread 1 waiting for resource 2. Thread 2 waiting for resource 1. Both threads will not release the resources. Then it is called as deadlock. In the interview, they will ask a question. Can you write a program which will give the deadlock? To check your skill, they will ask. Once we get the deadlock, we cannot do anything. Nobody can do anything. Once the deadlock occurs, your program will hang. Your program will never terminate. But to check your skill set in the interview, they may ask to write a program which will give the deadlock. Can you write a program and can you show me how deadlock look like? Can we write a program? Can we see that? With the threads. Can you guys try that? Look at the diagram and can you try? Deadlock. At least try. At least try the program which will give deadlock. Write a Java program. If you run the Java program, it should give the deadlock. If you run the Java program, it should give the deadlock.